This video is about writing equations of lines. For example, given a line with that slope that goes through that point, let's write the equation of the line in all three forms. Starting with point slope form, which is y minus y1 equals m times x minus x1. M is the slope, and x1, y1 is the point. So we'll just replace those. Y minus 2, that's the y value from our point, equals m times x plus 6, because it was subtraction and negative. Box around that, that's the answer to part A. Slope-intercept form, y equals mx plus b, needs to have no parentheses and needs to have y by itself. So we will take our point slope form equation, get rid of those parentheses by distributing. Do that first. Distribute negative 1/3 times x, and negative 1/3 times 6 is minus 2. I need to get y by itself, so I'm going to add 2 to both sides, which actually gets rid of it from both sides. So in slope-intercept form, this is just y equals negative 1/3 x. Put a box around it, that's the answer to part B. And then standard form is ax plus by equals c. So really it's just rewriting the order of our slope-intercept form and then making sure that a, b, and c are all integers, whole numbers, no fractions. So we're going to start with the answer from part B, which was this. And I need to move that x term to the front so that it's in front of the y on the left side of the equation. Because there's nothing left on the right side of the equation, that'll just be 0 over there. And this side, we'll write it in the correct order. We want our x term first, then our y term. There's nothing left over there. But I need this to be integers, integer coefficients. So I'm going to multiply this whole equation by 3, which will knock out that 1/3 and just make it x. Y becomes 3y, and 0 times 3 is still 0. And that's the equation in standard form. Another example says, given a line that goes through 2 points, and it gives us 2 points, we're going to write the equation in all three forms. So instead of giving us a slope at 1 point, it gives us 2 points. So we'll just have to start by calculating the slope ourselves. So slope, as we remember, is m equals. We're going to subtract the y values on top of the fraction, subtract the x values on the bottom of the fraction, simplify the top and the bottom. So 2 minus 4 is negative 2. Negative 1 plus 5 is 4. That reduces to negative 1/2. So there's our slope. So now I'm ready to fill in point slope form. Point slope form is y minus y1 equals m times x minus x1. I need to fill in my m with that negative 1/2. And for x1, y1, I can use either of the 2 points that I'm given. So I'll use the negative 5, 4. Y minus 4. My m was negative 1/2. In parentheses, put x plus 5 because it's minus a negative. And there's the answer to point A, question A. Get rid of the parentheses, get y by itself, put it in slope-intercept form. To get rid of the parentheses, we'll distribute negative 1/2 times x. Negative 1/2 times 5 is negative 5/2. We're going to add 4 to both sides. Adding 4 is like adding 8 over 2, so we have a common denominator there. So this side is going to say y equals, and this will say negative 1/2 x plus 3/2. And that's the equation in slope-intercept form. And then standard form, we need to get it in the correct order, ax plus by equals c, and then get only integer coefficients. So we'll start by adding this 1/2 x to the front of the equation. So it'll be written as 1/2 x plus y equals 3/2. Then we need to distribute a 2 by this entire equation to make these become integers. So 2 times 1/2 is just x, 2 times y is 2y, and 2 times 3/2 is 3. And that's the equation in standard form. Write the equation of a line that goes through 1, negative 3, so it's giving us a point, and is parallel to this line where they give us the equation in standard form. So parallel, you should remember, means the 2 lines have to have the same slope. So the only reason they're giving me this whole equation is so that I can determine the slope from it and reuse that slope. So I'm going to take that equation and convert it to slope-intercept form. I'm going to subtract the 2x from both sides. trying to get y by itself here. So 4y equals negative 2x plus 12. Divide both sides by 4 and reduce. So we've got negative 1/2 x plus 3. That's the equation in slope-intercept form, and I'm supposed to be parallel to that equation. So parallel means same slope, and the slope in this equation is negative 1/2. That's the only information I actually need from that equation. I don't need the 3, just need that slope. So it says write the equation of a line that goes from 1, negative 3, and has a slope of negative 1/2, and it doesn't say what form to write the equation in, so I'm going to write it in point slope form, since that's the information I have. I have the point and I have the slope now. So y plus 3, since it would be minus that negative 3, I'm using this as my x1, y1, equals m, which is the slope that I just got from my parallel line, times x minus 1. And I'm just going to leave it in that form and not bother converting it since it doesn't say. And if it wanted me to convert it to slope-intercept form, well then I would distribute and I would get the y by itself. Write the equation of a line that goes through 0, 4, and is perpendicular to this line. So it's a very similar question, but now it says perpendicular. And perpendicular slopes are opposite reciprocals. So again, the only information I need from that equation is its slope, which is negative 2, so that I can flip it and make it positive. So I want my new slope to be positive and flipped, so positive 1/2. So when I write my equation of this new line, I should also recognize that I'm given 0, 4, which is a y-intercept. So I might as well use slope-intercept form here since I have the slope. I just found it from the equation of that perpendicular line, and I have the intercept. So slope-intercept form is y equals mx plus b, where m is the slope, so y equals 1/2 x, and b is the y coordinate of the y-intercept, which here is positive 4. And then a tricky little question, write the equation of a line that goes through 1, negative 5 and is perpendicular to the line y equals 2. Now the line y equals 2, in case you haven't studied this in a while, is going to be a horizontal line. It's going to be the set of all points that have the y value of 2. So not only does it include that point, but it includes all points to the left and right of it on the same horizontal line. So y equals 2 is a horizontal line, and we're looking for one that's perpendicular to that. So we're looking for the equation of a vertical line. A vertical line will look like a line like this, but it has to go through the point 1, negative 5. If we're talking about going through the point 1, negative 5, we must be talking about the line, vertical line, that is located at x equaling 1. So the equation that's perpendicular to that and goes through 1, negative 5, is the line x equals 1.